Hi, I am Prakhar Kumar and I will be teaching you algorithm. In my previous video, I explained what all we will be covering in this course. So today we will be starting with the basics. So first of all, we will understand what is algorithm. Basically, what algorithm really is. I've seen many people getting confused of not knowing what algorithm is. So algorithm is simply a step-by-step procedure to execute a particular task. For example, there is a algorithm of, let's say, addition, in which it takes the input A, B, and gives the output A plus B. Now the input is 4 and let's say 6. The output will be 10. 17, 3, output will be 20. So with the difference in input, output is also getting different. But the base algorithm, the addition, that is simply the same. Algorithm don't adapt or learn. It just execute step by step. Now there are types of analysis, two types of analysis, a posterior and Aporean. A posterior is basically testing in real world and getting the real inputs. For example, testing a real car in a real world for mileage. That's the a posterior analysis. And Aporean analysis is platform independent, which we do on digitally to analyze a particular thing, which we will be learning throughout the algorithm. Now let's take algorithm testing. It's not a test, but let's test an algorithm. Let me write a simple statement. Let's say x, y plus z. So in this statement, what we are doing, first of all, we are doing an operation which is addition, and we are doing assigning to x. Now, in learning this algorithm, we will be treating this both as constant. We will be treating them as a constant and proceeding towards the question. Now let me take a for loop example for it to get a much better understanding. For I 1 to n x y plus z. So in this, first of all, let's see what we are really doing. First of all, initialize of I, which is time complexity of 1. Then we are doing comparison. If you have studied about for loop, we have to compare the value, which will, how many times will it compare in a for loop? N times. Then increment. And how many times we will be incrementing it? N times. And we will be executing this statement also N times. Comparison will be done. I'm sorry. Comparison will be done. Comparison will be done n plus 1 times. Why n plus 1 times? In for loop, when a for loop has to run for n times, it compares the value n plus 1 times to get out of the loop. Then we do the increment, and then this statement, which we can treat it as a constant, and you can also take some add this as an operation as a time complexity of 1 and assigning also 1, but we can treat this as a constant, which we can write, let's say 1, 1, or you don't have to write anything also, like we will be executing n times, so let's write n on. So if you add all these, 1 plus n plus 1 plus n plus n, what we are getting? We will be getting 4n, oh sorry, we will be getting 3n plus 2. So time complexity that we will be focusing, that will be n. We will be only focusing on this. The constant is always neglected, or we don't treat constant as much in algorithm, because we have to run the algorithm for longer period of time, and in that period we neglect the constant and focus on only the variable. So the time complexity of this for loop will be n. Now let's take more example. Let me write one algorithm for you. Let's say algorithm of sum, which takes input a, b, c, integer a, b, c, and okay, let's say read ab. If a is smaller than b, c is equal to a plus b. Else, else c is equal to a multiplied by b, and that's it. Print c. Now pause the video and look what will be the time complexity of this algorithm. Okay, so the time complexity of this algorithm will be big O of 1. Why? Because all these operations that we are doing, assigning, reading, if else, these and printing, these all take just time complexity of 1. Now let me take the another example to get better understanding of it. Let's say we are doing integer n and array of, let's say, n for I 1 to n. Sum is equal to sum plus 1. Print sum. Sum is also an integer we are taking. So here what we are doing is we are adding 1 to the variable sum n times, and we are keep on repeating it, and then print the sum. So the time complexity of this algorithm will be big O of n. Now you don't have to get or worried about the big O of n, big O. We will be explaining in the future videos, but time complexity will be big O of n. So this is for the video. In the next video, let me write topic of it. In the next video, we'll be discussing about big O, big theta, and big omega. We'll be discussing about these things in the next video. Thank you.